Hello. So for today, our topic is on linear programming. So what is linear programming? So linear programming provides a method for allocating limited resources among competing activities in an optimal way. So this is actually a method that would help you assist when you make decisions. Now from the term linear, no, so all mathematical functions are linear. So some application of linear programming, we have manufacturing, like how many products are you going to make, marketing, where are you going to market, or any method that would help you, no? We also have finance, where you're going to invest your money, also for advertising and agriculture. Okay, so in linear programming, we have the linear programming model. So this is actually a function, okay, that maximize or minimize our linear function, subject of course to the set of linear constraints or limitations. So of course, your linear programming model consists of decision variables, unsa tong atong gipangita. Then you also have the objective function, what's your goal, and what's the set of constraints, which is the limitations. Okay, so how are we going to formulate our linear programming model? So first is you have to identify the decision variables. How many units to buy or sell? Okay, so buning imong ilat X or Y. Okay, how much time to spend on a task? So these are just examples. No? Next is you are going to measure, the measure of performance is the objective function. So what's the goal? Usually in your objective function, we have maximizing the profit or minimizing the cost. Okay. And of course, this is a function of the decision variables. Next is restrictions of values of decision variables set in constraints. So usually these are mga limitations mo like minimum acceptable profit or unsay mga available resources lang. And lastly, we have the parameters, which are the constant, no, of the objective functions and the constraints. So these are just mga numbers nga inyo makita sa problem. Okay, so you have nothing to worry on this. So here is the general structure of your linear programming model. So first thing you have to do is you have to write the objective function. So in ano yung itsura, z equals, okay, ang mga equation. And then you have subject to, and then mga equations sa imuha are usually inequalities, no? Naka-inequalities, mga restrictions nimo. Okay. And lastly, since this is a real life problems, ang imuhang mga variables should be greater than or equal to 0. So this is our non-negativity constraints. So let's have our first example. So a chocolate manufacturing company which produces only two types of chocolates, A and B. Okay. So both of the chocolates requires milk and chocolate. So to manufacture each unit of A and B, following quantities are required. Each unit of A requires 1 unit of milk and 3 units of chocolate, and each unit of B requires 1 unit of milk and 2 units of chocolate. So the company kitchen has a total 5 units of milk and 12 units of chocolate. On each sale, the company makes a profit of 6 pesos per unit of A and 5 pesos per unit of B. So the company wishes to maximize the profit. So how many units of A and B should it produce respectively? Okay. So to easily understand the problem, it would be easier to it would be better if you're going to construct a table, no, of the information sa nga nasa problem. Okay? So we have two products, A and B. So this is A and B. Okay, and then we have the ingredients, milk and choco. So for A, it needs 1 milk. Okay, here, 1 milk, 1 milk, and 3 units of choco. And for B, it needs 1 milk and 2 units of choco. So 1 milk and 2 units. Okay, it says here that there are 5 units of milk and 12 units of choco ang available lang. So, dapat ita mula pa so 5 units of milk and 12 units of choco. That would mean ang imong resources should, imong milk na magamit should be less than or equal to 5 lang. Kay mura man ang available. And less than or equal to 12. Kay mura sa ang available na choco. And now for the profit. Okay. for the profit, na kay 6 pesos para sa A and 5 pesos para sa B. So that would mean kani is 6 pesos, and for the B, you have 5 pesos. Okay, and the company wishes to maximize. So kani ang profit, i-max nato, no? Ang yaning pangutana is how many units of A and B. So kani ang imong decision variable, may mong question, di ba? So let this be our X and let this be the Y. Okay. So, naray mong table, na-summarize na nito ang information sa atong problem. So, how are we going to construct our LP model? Okay. So, here, same table. Huh? So, first up is, of course, you have to write objective function. Objective function. Okay, again, our objective is to maximize the profit, no? So, Z max equals 6x plus 5y. Okay, and then your constraints, so you have to write subject to. Okay, so you start with this milk. So you have x plus y is less than or equal to 5. And then for the choco, you have 3x plus 2y less than or equal to 12. And lastly, don't forget the non-negativity constraint that dapat imong x is greater than or equal to 0 and your y is also greater than or equal to 0. And this is now your LP model. Okay, so in the exam, if you will be asked to write the linear programming model of the problem, so kanira yung answer. Okay, now, once you have the LP model, you can now start solving for the optimal solution. But before we go on with that, let's define some terms, no? So when we say solution, so these are the values of your x and y that would satisfy your constraints. And then we have the feasible solution. Okay. So solution is specify values for your decision variable. Say values imong x o imong y. While a feasible solution would satisfy the constraints. Okay, of course, the infeasible solution is katong mga values sa imong x o y nga dili mo satisfy sa imong constraints. And then, si feasible region, no, is the collection of all feasible solutions. So, kung i-graph ni mo imong problem, nadari mong feasible region. Okay, and then we have the optimal solution, which is the goal of using linear programming. Okay, so this is our solution, no, feasible solution. So it satisfies all the constraints, no, values of your x and y, but of course with the most favorable values in our objective function that would give you the best answer. Okay, but to do that, to identify that optimal solution, so we have the corner point feasible solution. Usually, among optimal solution are located at the corner points. So in this graph here, it should be any of these points. So these are your corner points. Okay, so this graph is actually an example of a maximization problem. Okay, but when you have a minimization na graph, usually inani ang itsura. Ang yahang feasible region is nasa taas, padulong sa taas. Okay, so in this case, ang imuhang corner points would be this point here, this here, and this point. Okay, at least you have an idea sa itsura when you have maximum or minimum na mga problem. Going back with our first example, no, we have here our objective function already and the constraints. Okay, so when you graph that one, we use I actually use Desmos. Okay, but maybe in the exam the graph will be given, so you have nothing to worry with that, with the graphing. So with the Desmos, all you have to do is you type in the constraints here, no? So see here, the red one is, this is actually your x plus y less than or equal to 5. And the blue one is your 3x plus 2y less than or equal to 12. Now, your feasible region here should be in the quadrant 1 lang. So, kani this, kani kay mumara ni ang area nga nag-overlap ang duha. And for our corner points, we have this points here. Okay, So we have, so this here is our 0, 0, okay, and then here is you have 0, 5, and this one here, this one here is, that's 2, 3, okay, and then here is you have 4, 0, okay. Alright, so naray mo mga corner points and kana lang imong kinahanglan kwaon, okay, so that we will be able to determine our optimal solution. Now, how to know which of these corner points ang atong optimal solutions? What you're going to do is just make use of the objective function, okay, and substitute the values of your corner points or the x and y. So in here you have 6 times 0 plus 5 times 0. So obviously wala gid kay profit kay wa makagi-produce nga product. Okay, next is you have 6 times 4 plus 5 times 0. So this will give you a profit of 24. Okay, and then you have 6 times 2 plus 5 times 3. So this is 27. And 6 times 0 plus 5 times 5 equals 25. So looking at the results, so we could say na this one here has the highest profit. So that would mean our optimal solution would be occurs when the company produces 2 units of type A chocolate and 3 units of type A chocolate with an optimal profit of 27 pesos. All right. Okay. Next, let's have another problem on minimization. Okay, so this is to minimize. Okay, so a rancher is mixing 2 types of food, brand X and brand Y, for his cattle. If each serving is required to have 60 grams of protein and 30 grams of fat, where brand X has 15 grams of protein and 10 grams of fat that cost 80 pesos per unit, and brand Y contains 20 grams of protein, 5 grams of fat, then cost 50 pesos per unit. How much of each type should be used to minimize cost to the rancher? Okay, so we have here brand X and brand Y. So let that be also our variable since moment po diyang gipangita, no? And how much of each type. Okay, now for brand X, okay, si brand X daw has 15 grams of protein, 10 grams of fat, and cost 80 pesos. So si brand X na siya 15 grams of protein, 10 grams of fat, and na siya cost of 80 pesos. And then for brand Y, you have 20, 5, and 50. So you have here 20, 5, and 50 pesos. Okay. Next is we have here, no? Each serving, kinahanglan niya na ay 60 grams of protein and 30 grams of fat kung mag-mix siya atong brand X and brand Y. So requirement, so dapat dili siya maubos. So ang imong protein should be greater than or equal to 60 and your fat should be greater than or equal to 30. And of course, since the goal of this is to minimize the cost, so that means we're going to minimize this. Min Z. Okay. Alright, so let's now move on to writing our linear programming model. So first is you have your objective function. So this one, now we want to minimize the Z. So Z mean the cost. So that's 80x plus 50y. Next is subject to your constraints. So this one should be greater than or equal. So you have 15x plus 20y should be greater than or equal to 60. And then as for the fats, you have 10x plus 5y should be greater than or equal to 30. And lastly, the non-negativity constraints, no? Your x and y should be both greater than or equal to 0. And this is now our linear programming model. Again, if you are asked to find the linear programming model of the problem, kanina inyong answer. Okay? But if you are asked to solve, now given the graph, okay, so you have to determine the feasible region and the corner points. So in this case, our feasible region, no, after inputting our constraints, so narata sa quadrant 1. Okay. Most probably in the exam, ihatag nila ang graph. Okay, and for corner points would be this points here, no? Kung asa nag-overlap ang duha. So here we have, this is 0, 6, and this one is 2.4 and 1.2, and this one is 4, 0. Okay, so we have 3 corner points. Okay, now to find the optimal solution, again, we're going to use the objective function, substitute the values of our corner points. So in this case, you have 4 times, so you have 80 times 4 plus 50 times 0, which is equal to 320. If you have 80 times 2.4 plus 50 times 1.2, that would give you a cost of 252. And then when you have 80 times 0 plus 50 times 6, that would give you a 300 na cost. So looking at the result, you can see that this one has the minimum cost. So that would mean our optimal solution occurs when the rancher will use 2.4 grams of brand X and 1.2 grams of brand Y to minimize the cost to 252 pesos. And that's the end of the topic. Okay, so if you have questions, feel free to message me. Thank you.